Hello, everybody. So this is going to be the last session of polymer chemistry. So let's start. Note down the heading, kinetics of polymerization. All right. So let's say that you have a monomer A. Some monomer A, it combines with another monomer A to form the polymer. So initially, at T is equal to 0, if the concentration of each of the monomer, let's say initially is A naught, so before polymerization, polymer won't be formed. And A naught, we are familiar with this, is the initial concentration of monomer. Now, after a while, at some time T, some amount of each of the monomers will undergo polymerization. It can be condensation, it can be addition, whatever, X amount. So X is the amount of monomer consumed. Amount of monomer consumed. And some amount of the polymer would be formed, that is also going to be equal to X. So here, A naught minus X, that is initial concentration of the monomer, minus whatever is consumed will give you the final concentration of the monomer at time T. If so, you already know this is also 80. This is also 80. Correct. This is also 80. So, in that case, we define something called degree of polymerization. Degree of polymerization. Degree of polymerization is very simply represented by like this. N in brackets, and that is equal to initial concentration of the monomer divided by final concentration of the monomer is one equation. That is one equation. Okay. Now there is another equation which can be applicable only to addition polymers. I'll tell you the reason why. For example, degree of another equation, okay? Degree of polymerization is equal to mass of the polymer divided by mass of the monomer. Let's say you have 10 units of ethylene and it undergoes polymerization. So it's going to be a homopolymer, correct? Then only you can use this. There should be some pattern. There should be one unit which keeps on repeating. So 10 units of ethylene will give us polyethylene 10 times. Okay. Now, how can we find this? Let's say you don't know what N is. How many monomers are there? Let's say you don't know. Instead, they have given you that the mass of the polymer, mass of the polyethylene, let's say it is given to be 280. You have to find the mass of the monomer. You know what the mass of the monomer is? 2 carbons. So 2 into 12 plus 4 hydrogens, 4 into 1. And that is going to give you 12 twos are 24 plus 4, 28 grams per mole. So 280 by 28, you have 10 monomers in it. You have 10 monomers. So this can also be used to find the number of monomer units in the polymer. But the problem is this is not applicable to condensation polymers. Why? Because in condensation polymers, it's not just the monomers merging together via free radical mechanism. No, there is a loss of water. There might be a loss of ammonia. There might be a loss of alcohol. So ideally, this can be used only for addition polymers like polyethylene. Otherwise, you will be going with this equation, that is final concentration of the monomer. Sorry, initial concentration of the monomer divided by final concentration of the monomer. That is degree of polymerization. Let's do a question. The degree of polymerization at time t is equal to 10 hours of polymer formed by stepwise process with rate constant 3 into 10 to the power minus 2 per molar per second, and initial concentration of monomer equal to 50 millimolar is. So you have to find the degree of polymerization. Time is given, initial concentration is given, rate constant is given. Options are 55, B 65, C 550, D 505. Question was asked in 2020. Okay. So how to start? Already you know that the degree of polymerization is equal to the initial concentration of the monomer divided by the final concentration. But you know only the initial concentration, it is given in the question. So how to find the final concentration? Okay, now if you look at the rate constant, see the units. It is per molar per second. Per molar per second, and hence you can confirm that the order of polymerization over here is 2 by just checking the units of the rate constant. Now, if it is 2, you know that 1 by A minus 1 by A naught is equal to rate constant into T. You know that. This is the integrated rate equation for second order reactions. So we need to find the final concentration at any time T, correct? And that is equal to 1 by initial concentration is 50 millimolar. So you will make it into molar. 10 to the power minus 3 molar. Plus, what is the rate constant? Rate constant is 3 into 10 to the power minus 2 per molar per second, and you have to multiply it with time, but the time is given in hours, so you have to convert it into minutes. No, you have to convert it into seconds. So 10, 1 hour is 60 minutes and 1 minute is 60 seconds. So this much seconds. Correct? So per second and second gets cancelled. So finally, what you get is 1 by A, I have already calculated it, is 1100. This molar comes to the top. Per molar can be added and it becomes per molar. Or concentration of A is equal to 0.9 millimolar it is. We can take the reciprocal and we can find the final concentration. Okay. So, very easy. Degree of polymerization is equal to the initial concentration, which is 50 millimolar, divided by the final concentration, which is 0.9 millimolar. That is equal to 55.5 is what we get. And the correct option is option A. A very beautiful question, which is connected with chemical kinetics. So it's a good one. Okay. One more question, similarly related to chemical kinetics itself. Please write. The reaction rate of a self-catalyzed polyesterification reaction is given by minus d by dt of COOH is equal to rate constant into concentration of COOH to the power 2 into concentration of OH. If M naught is the initial concentration of OH and COOH monomers, then degree of polymerization is given by So please try it out by the time I write down the options. This was asked in 2019. Try it out. Option A, degree of polymerization is equal to 2 times m naught square K T. Option B, degree of polymerization square is equal to 2 m naught square K. C, degree of polymerization square is equal to 2 m naught square Kt plus 1. D, degree of polymerization square is equal to 2 m naught Kt plus 1. Very beautiful question related to chemical kinetics again. Try. Pause the video and try. Okay. So already it is given that the rate of the reaction is depending as follows. So there is no other hint given. So we can see that the rate of the reaction is equal to rate constant into carboxyl ion concentration to the power 2, hydroxyl ion concentration to the power 1. Correct? So from this, you can get the total order of the reaction as 3. Total order of the reaction is 3. So if it is a third order reaction, we already know the integrated rate equation. It is 1 by A square minus 1 by A naught square is equal to 2KT. Correct? This is the equation. How did I get this? The general formula for any order reaction is 1 by A to the power n minus 1 minus 1 by A naught to the power n minus 1 is equal to n minus 1 into KT. Okay, this is the integrated rate equation for any order reaction where n cannot be put as equal to 1. For rest any values, this can be used. Okay, so let's start with whatever is given in the question. We understood that it is a third order reaction. And for that, you should know the basics of chemical kinetics, correct? Instead of A, they have written in terms of M. So we will also write it in terms of M. So let's start. 1 by M square is equal to 1 by M naught square plus 2KT. Or if I cross multiply this, Okay, I'll first, in order to avoid confusion, I'll take the LCM on the right. So it becomes 1 plus 2 m naught square kt by m naught square. Now I'll take the reciprocal on both sides. Or simply, instead of taking the reciprocal, I'll take this term over here. So let's see what it becomes. M naught square divided by m square is equal to 2m naught square kt plus 1. Already we know that the degree of polymerization is just m naught by m. But instead what we have here is m naught square by m square. So this is equal to the square of degree of polymerization, and the square of degree of polymerization is 2m naught square kt plus 1. Square of degree of polymerization is 2m naught square kt plus 1, and the correct answer is option C. Correct answer is option C. All right. Next question. The degree of polymerization. The degree of polymerization, N, and fraction of monomer consumed. Fraction of monomer consumed, which is written as P, for polymerization reaction are related by. Again, I have told you several times that when this word fraction comes, you have to pay attention. We have already done many questions in chemical kinetics. Okay, are related by option A. Degree of polymerization is equal to 1 by 1 minus P. Option B, degree of polymerization is equal to 1 by 1 plus P. Option C, degree of polymerization is equal to 1 by P. And option D, degree of polymerization is equal to 1 by P squared. And this question was again asked in 2019. Okay, let's start. What is degree of polymerization, first of all? We'll start from what we know. Degree of polymerization is initial concentration of the monomer divided by the final concentration of the monomer. What is the final concentration of the monomer? So the final concentration of the monomer is the initial concentration of the monomer minus the amount of monomer consumed. We already know that. We have written it. It is the amount of monomer consumed. Correct. Now, what is the question? They have asked us to find the relation with the fraction of monomers. Sorry. Related to the fraction of monomer consumed. So, fraction of monomer is represented by P in the question. And that is going to be the amount of monomer consumed divided by the initial amount of the monomer. This is a fraction. So you have to bring this term. So you have to bring this term. X by m naught is what you need. So how do you bring that? Very simple. You divide the numerator and the denominator with m naught. So what do you get? Degree of polymerization is equal to 1 by m naught is 1 minus x by m naught. And that's what you want, 1 by 1 minus p. Option A, 1 by 1 minus p, option A. Very important, huh? So this is the third equation that you can add. So in the beginning, we have written two equations. 1 degree of polymerization in terms of just the monomer concentration initially and finally. To this, you can also add that the degree of polymerization is equal to 1 by 1 minus P, where P is X by A naught, fraction of monomer consumed. Fraction of monomer consumed. That is another equation. Okay? Easy. Now, last part, Florey theory. Florey theory. You have to learn 2-3 equations, that's all. With that, you'll be able to do any problem. So it says that for a n-mer, that means there are n monomer units. Okay. So for a n-mer, the probability of linking n monomers. So probability again is P, and linking n monomers is P to the power n minus 1 into 1 minus P, where just P is the probability of linkage. What is the probability of linkage? This one, just P. And 1 minus P is the probability of not linkage. Probability of no linkage. 1 minus P. So this is a theory which was put forth by Florey. Okay, so for example, if you have a trimer, where the value of n is equal to 3, correct? So the total probability of linkage, is going to be equal to probability of linkage to the power 3 minus 1 into probability of no linkage. So that is P square into 1 minus P. Okay, so this is the Florey theory. And there is one more equation over here, which is the average value of links, K average. K average is the average value of links that is equal to 1 by 1 minus P. Please don't get confused. You have already learned an equation where degree of polymerization is equal to 1 by 1 minus P, where this P is the fraction of monomer consumed. Correct? It is the same equation with the same notation. K average is equal to 1 by 1 minus P, where this P is the probability of linkage, which we have already written over here. It is the probability of the linkage. P, probability of linkage. That is the average value of links. This is also related to our number molecular average mass as mass of the monomer divided by 1 minus P. This is mass of the monomer, and P is again the probability of linkage. So these are the equations that you should know from Florey theory, and with that we can do any problem. Okay? That's it. So we have learned 3 equations from the degree of polymerization. One in terms of just dividing the mass of the polymer divided by the mass of the monomer. Second one in terms of the initial concentration and final concentrations of the monomer. And third one in terms of fraction of monomer consumed. P is the fraction of monomer consumed. Okay? And under Florey theory, we have learned some equation that is based on the probability of linkage. The total probability of linkage is probability of linkage to the power n minus 1 into probability of no linkage, which is 1 minus P. And average value of links is equal to 1 by 1 minus P, while the number average molecular mass is equal to mass of the monomer divided by 1 minus P. That's all. And with that, we have completed polymer chemistry. Okay. You will have one more assignment, one or two more assignments, and with that, we are done. All right. So thank you.